Hello, I'm Danura Kalehewaththa. This is a mathematics video. I'm discussing about the maximum, minimum and point of inflection. And I'm using the differentiation concept for this one. So then if I talk about a minimum, so I can write minimum point as a x squared, we know curve like this, fx equal x squared. So my previous videos I'm explaining how to shift the curve. So then if I shift this one here, it will be fx minus 1. Then it should be x minus 1 square. So axis of symmetry will be x equal 1. So if I shift that to vertically upward 3 unit, it will be like this. So then I'll take y equal x minus 1 square plus 3. So separately if I draw that graph again, so it will be like this. Here 1 and here 3. This will be x and this will be y. Right. We see this point we know already it's a minimum. Right. I'll differentiate this. Right. Then it will be dy by dx equal x minus, no, I'll expand the bracket because we then more convenient to see the convenient to explain that term, even though here also we can differentiate, but still I'll expand it. 2x plus 1 plus 3 y equal x square minus 2x plus 4. So I'll differentiate this one. Dy by dx equal 2x minus 2. Right. In maximum minimum point, we know that dy by dx equal to 0. That means if I draw a graph like this, maximum, minimum and point of inflection, these points dy by dx 0. And if I substitute that values, like example here, if it is this one A and this one B, this one C, if I substitute dy by dx x equal A, I am getting 0. Same pattern, dy by dx, if I substitute V, I am getting 0. Same pattern, dy by dx, if I substitute C, I am getting 0. So I'll come to that later. Now I am discussing about this one. So I'll come to that like this. Then I don't I don't know maximum, minimum and stationary point dy by dx 0. Then I'll write in stationary point dy by dx equals 0. That means 2x minus 2 equals 0, 2x equal 2, x equal 1. Right. We know maximum minimum point we have in x equal 1. Like very simple to understand. Right? Quadratic form I have done previous lesson. You can go to that one also. Then we know the minimum point is 1. Then I got the differentiating that one. So I'll differentiate this one by again. Then dy by dx we have 2x minus 2. I'm differentiating again. That means double differentiation greater than 0. We have minimum value. That means when x equal 1, we have minimum value. So then I can write when I can write y equal fx when x equal a is stationary point. It means dy by dx, if I substitute x equal a, I am getting 0. The bracket is right. Then d squared by dx square greater than 0 when x equal a, we have minimum value. Right, then I come to the maximum value. Maximum value will come. Maximum. Again, I'll take the curve as usual. I'll take maximum value y equal minus x square. Then I'll take as a gx minus x square. I'll shift it x minus 2 if minus 3 if I take, we have x minus 3 square. Vertically if I shift x minus 3 plus 2. Shifting this one, curve will be right there. This will be 3. Then axis of symmetry this one. Curve goes upward. It's going to be 2. Then clearly if I draw the graph will be like this. This will be 3. This will be 2. This curve will be minus x minus 3 square plus 2. Right. As usual, I'll expand that one. Y equal minus square minus 6x plus 9 plus 2. Minus x square plus 6x minus 9 plus 2. Y will be minus x square plus 6x minus 7. Now, in stationary point, dy by dx equals 0. Then I'll differentiate this one, dy by dx minus 2x plus 6. Then it will be minus 2x plus 6 equals 0. Minus 2x equals minus 6. It should be, you see, maximum point here. Then we'll differentiate again. We have minus 2 lesser than 0. That means when d square y by dx square negative at x equal 3, we have maximum. Have that theoretical form that one. Right. F gx y equal gx curve, we have x equal b as a straightener point. That means dy by dx equal b if I substitute dy by dx, x equal b if I substitute, I am getting 0. Then d square y by dx square x equal b lesser than 0, we have maximum. Right, next case. Now we have 3 cases now. One we have minimum, maximum and point of inflection. Right, then I'll come to the point of inflection. Again curve translation I'll do. Then point of inflection. If I take a curve like this, we all know y equal x cube curve like that. If I shifted that one in 2 units, then if I take as this as hx x cube x minus 2, no? That will be x minus 2 cube. If I translate 3 units, then I have to add 3, no? That means I'll take y equal x minus 2 cube plus 3. That curve will be clearly, I can draw here too. Curve will be like this. Then I'll expand this one to our convenience. Multiplying 1 by 1. S cube S cube whole square plus 4x negative 2x square S cube 4x square 4x minus 2x square plus 8x minus 8. Then y equal S cube 6x square plus 12x minus 8. So we differentiate this one. Differentiate. dy by dx 3x square minus 2lx plus 12. In stationary point, dy by dx equals 0. Then 3x square 12x plus 12 equals 0. X minus 2 square. Repeating roots. Then we got the stationary point at 2. Right. Then you differentiate again this one. X minus 12. And now substituting x equal to 0. What a case then. What will do this? We know stationary point is 2, but double differentiation we getting 12. Again differentiating. 6. Then not equal to 0. Then we have point of inflection at x equal to. So we will take a theoretical form that one. If y equal fx curve has point of inflection at x equals c, then we have dy by dx x equals c equals 0 and d squared y by dx square, that also 0, but dy by dx cube equals 0. And this condition we have is a point of inflection. So that's the maximum, minimum and point of inflection identification, and just like to find and determine, and that's the concept we can use for the differentiation for that thing. And that, thank you for watching this my maximum, minimum and point of inflection concepts, and we'll do another lesson for the further mathematics and statistics and physics.